18,000 years ago, the Zealandia Switch decimated Earth's glaciers. Has it returned? This is by Andrew Laurie and colleagues, The Conversation on Science Alert. Earlier this month, we wrapped up the latest annual end-of-summer snowline survey over New Zealand's South Island, Te Waipunamu, providing a bird's-eye view of how glaciers fared during the past year. This collection of aerial photos adds to nearly half-century perspective of irrefutable, dramatic climate change impacts on New Zealand's frozen landscapes. To put it bluntly, New Zealand's glaciers look emaciated. Another Tasman Sea marine heatwave punctuated the hottest year on record nationally at the close of 2021, bathing the Southern Alps in warmth. That pattern continued in the Southern Hemisphere summer of 2022. As New Zealand's glaciers continue to feel the heat and shrink, bedrock that has not seen daylight for ages becomes exposed. Basins filled with meltwater begin to multiply across the landscape. In many cases, a ring of dirt and rock around some of New Zealand's largest lakes marks where ice once reached. Our current research is exploring these exposed rocky ridges to retrace New Zealand's climate history. Fingerprints of change in the landscape. The ridge-like mounds of rocks retreating glaciers leave behind are called moraines. Directly in front of some of the largest Southern Alps glaciers, fresh moraines circumscribe turquoise-tinted lakes with ice calving into them. This scene does leave room for denial of the rapid retreat of ice from the alpine landscape. Downstream, more extensive moraines were wrapped like ribbons around massive lake basins that lie along the edge of the Southern Alps. Some of these landforms stretch for miles, and they illustrate ice was much more extensive in the past. We know the processes that formed those moraines must have been similar to what we observe today, but how old are they? What happened to the massive ice that was once there? And why did it retreat? A new mechanism that explains a rapid shift at the end of the last ice age, called the Zealandia Switch, is found in New Zealand moraine evidence. This new hypothesis is challenging a long-held view about why glaciers changed in the recent and distant past. While the Zealandia Switch focuses on global ice retreat for prehistoric times, we think it may also explain what is happening right now with our glaciers. Clues from a nearly sunken continent. Glacial geologists use rare chemical isotopes trapped in rocks to trace the histories of Earth's surface with a technique called cosmogenic surface exposure dating. The method measures how long rocks found on the surface today have been exposed to cosmic rays. Boulders that have been carrying inside flowing ice have zero exposure history. When they are dropped into a moraine and exposed to cosmic rays from outer space, their cosmic clock starts and the rare isotopes begin to accumulate inside minerals in the rock. Once exposure dates for moraine boulders are established, they're linked to detailed maps that outline ice advance and retreat sequences. The major moraines around central Southern Alps lakes, Pukaki, Tekapo, and Ohau, now have hundreds of results showing rapid change happening about 18,000 years ago. Offshore in the Tasman Sea, microfossils from sediment cores indicate ocean currents and boundaries shifted at exactly the same time. Climate modeling can explain the simultaneous land and sea changes through a major switch of southern hemisphere westerly winds over the nearly submerged Zealandian continent, hence the Zealandia Switch hypothesis. When the Zealandia Switch turns on and spins up the southern westerlies, it helps to promote water vapor export from the tropics and atmospheric circulation patterns that drive warming in both hemispheres. If the Zealandia Switch hypothesis is upheld, then the story about Quaternary Ice Age origins and their impacts on global climate, plant ecosystems, and ancient fauna will need to be rewritten. The Zealandia Switch and ice loss. Fast forward 18,000 years, and the southern wind of change are now on the move again, subtropical waters are being pumped into the Tasman Sea, driving more frequent marine heat waves. New Zealand's temperatures are soaring. Atmospheric rivers loaded with tropical moisture are penetrating Antarctic latitudes and bringing record temperatures with them. The current situation has hallmarks of the Zealandia Switch playing an enhanced role, but this time Earth is in an interglacial rather than an ice age state. The latest Southern Alps glacier research shows austral warm season temperatures and a rising snowline trend are tightly coupled. The rising snowline trend is also accelerating at an alarming pace. The series of extremely hot years with exceptionally high snowlines that are driving this pattern have been linked to anthropogenic greenhouse gas emissions. Similar conclusions have been drawn from the recent acceleration of global ice loss. These connections raise the possibility that human activities have flicked the Zealandia Switch to a higher level of the on position, and it may remain stuck there for the foreseeable future. If what unfolds is anything similar to when Zealandia Switch curtailed the ice age during the last glacial termination, we can expect big, fast, and global climate reorganization impacts. The changes ahead may also bring the beginning of the end of final termination for many glaciers north and south. This was from Andrew Laurie, Principal Scientist, Programmer, Leader of South Hemisphere Climates and Environments, National Institute of Water Atmospheric Research, Associate Professor, University of Maine, David Barrell, Geologist and Geomorphologist, GNS Science, George Denton, Professor, University of Maine, and Jolyn Russell, Professor, University of Arizona, on the conversation, Creative Commons here on Science Alert. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.